reflection of light in spherical faces. Before it discussion, we know the characteristics of images formed by a plane mirror. Characteristics of images formed by a plane mirror. Plane mirror. Characteristics of images formed by a plane mirror. Number 1, the image is virtual. Image is virtual. That is not real. The image is virtual, upright or erect. Virtual, upright or erect. Upright or erect, and the same size as the object. The image is virtual, upright or erect, and the size of the image as the object. And the size of the object. The size of the image is as the size of the object. Is as the size of the object. The size of the object. First point. The image is virtual, upright or erect, and the size of the image is same right here, is same as the size of the object. Number 2, the image is formed behind the mirror. Behind the mirror, the image is formed behind the mirror at the same distance as the object is in front of it. In front of the mirror, in front of it. Object is in front of it. The image is found behind the mirror at the same distance as the object is in front of it. Same distance from the mirror, obviously, as the same as the object is in front of it. Number 3. The image is laterally inverted. The image is laterally inverted. Number 3. Point 3. Point 3. The image is laterally inverted. Laterally inverted. The image is not inverted. The image is laterally write it clearly. Laterally changed. Image is laterally changed. Image is laterally. That is lateral inversion. The image is right. The image is laterally inverted, right? To give some other language, the image is laterally L-A-T-E-R-R-A-L-Y. The image is laterally inverted. Remember it. Some other points are given in the next class. Now we know some terms about spherical mirror. Spherical mirror. It is a part of sphere, obviously. It is a mirror which is part of a sphere. Spherical mirror are of two types: concave mirror and convex mirror. It is a part of a sphere whose one surface is silvered. It is a part of a sphere whose one surface is silvered and the other acts as a reflecting surface. There are two types of spherical mirrors. Generally, there are two types of spherical mirror. Two types of spherical mirrors. Two types of spherical mirrors. Number one, concave mirror. We know it, its definition also. This is a concave mirror whose outside surface, that is bulging surface, this is the bulging surface, is silvered, and this portion, that is this portion, is a reflecting surface. This is a reflecting surface. And in the case of this situation, in which the inner part is silver, this is called convex mirror. Convex mirror. In a concave mirror, this is concave. This is concave mirror and this is convex mirror. Concave mirror, convex mirror. Now some terms about spherical mirrors. We discuss some terms about spherical mirror. Some terms about spherical mirror. Number one, pole of a mirror. Pole. This is indicated by capital P. Pole of a spherical mirror. The central point or midpoint. central point. The central point or midpoint of a spherical mirror is called pole of the mirror. Pole of the mirror, right? We take a concave mirror. Here, the bulging surface is silver. Then its midpoint will be this. It is the pole P. In the case of convex mirror, this is concave mirror. Concave mirror. And this is convex mirror. This inner portion is silver. Its midpoint is, hence it is the pole of the mirror. This is the pole of the mirror. The central point or midpoint of a spherical mirror is called pole of the mirror. Spherical surface. Here, the central point or midpoint of the surface of a spherical mirror is called surface. This must be the surface. The surface point, a midpoint of the surface of a spherical mirror is called pole of the mirror. In the figure, P is the pole of the mirror. Now, center of curvature. Center of curvature. Center of curvature. Center of curvature. The center of the sphere of which the spherical mirror is a part is called center of curvature. The center TRE, maybe right, or TR maybe. The center of the sphere TR may be written. The center of the sphere of which the spherical mirror is a part is called center of curvature of the spherical mirror. Center of curvature of the spherical mirror, of the spherical mirror. Center of curvature. Like in this case, we see the figure, another figure. The center of the sphere of which the spherical mirror is a part is called the center of curvature of the spherical mirror. We see it in figure. These both are in a figure, in two figures. one figure is a concave mirror. This is a concave mirror in which bulging surface is silvered, and this is the convex mirror in which the inner surface is silvered. Hence, if we complete the sphere, we have like this. Like this. Its center is at this. That is, C is the center of curvature. This is P, this is C, because if we complete the sphere, then C is the center. C will be the center. Hence, center of curvature this, and this is 4 already mentioned. Now, we just discuss what is the principal axis of a spherical mirror. If we join the center of curvature and the pole, center of curvature and the pole, and extended both sides, then this is called principal axis. What is principal axis? Principal axis. This is principal axis. This is principal axis. If we join by a straight line of pole and the center of curvature, then this line, when extended on both sides, is called the principal axis. Now, what is the radius of curvature? Radius of curvature is the radius of the sphere of which the spherical mirror is a part. That is, in this case, this is the R. This is the R. Hence, radius of curvature is the radius of a spherical mirror of the sphere of which the mirror is a part. Right. Now, we know about focus. Principal focus. Principal focus. F. Principal focus. We draw a figure and just lecture it. You are all write in your exercise book. Principal focus. We take two mirrors. One is concave, that is, bulging side is silvered, outside surface is silvered. Now we have already the C, pole P, C center of curvature, and the principal axis, X prime. In the case of convex mirror, the inner portion is silver. Here we discuss what do we mean by a concave mirror in another definition. Concave mirror is that mirror, that spherical mirror, in which the reflecting surface lie along the center of curvature side. But in the case of convex mirror, the reflecting surface is not along the in the side of center of curvature. In the side of center of curvature, it is silvered. P C, center of curvature. This is principal axis. Now, if a parallel beam of light rays, parallel beam of light rays are incident parallel to the principal axis on the reflecting surface of a mirror, here on the reflecting surface of a concave mirror. This is concave, this is convex mirror, concave mirror. If a parallel beam of light are incident parallel to the principal axis on the reflecting surface of a spherical mirror, here we write this. Then, after reflection from the reflecting surface of the mirror, the reflected rays meet at a point on the principal axis, or meet at a point on the principal axis. Meet at a point on the principal axis. This point on the principal axis at which all the reflected rays meet is called focus, principal focus of a spherical mirror. Actually meet in the case of concave mirror. But in the case of convex mirror, the reflected rays actually not meet at a point, but appear to diverge from a point, from this point. Appear to diverge from this point. Appear to diverge from it. If the reflected rays proceed backwards, that is behind the mirror, then they meet at a point on the principal axis. This point is called the principal focus of a convex mirror. That is, we discuss it again. If a parallel beam of light rays are incident on the reflecting surface of a concave mirror or convex mirror, then after reflection they meet at a point on the principal axis. Here the incident ray must be parallel to the principal axis, or appear to diverge from a point on the principal axis, and these rays are also parallel to the principal axis, incident rays. Then this point on the principal axis is called principal focus. That is, in this case, F is the principal focus. F is the principal focus. F is the principal focus. Now, here aperture of a mirror are of two types. One is if we connect M1 to M2, then it is also called the aperture is diameter in this case, though it is not the diameter actually of the spherical mirror. This is 2 point M1, M2. Aperture. We join this aperture. Becomes aperture. Or angular aperture is this. If we draw M1 F, then this angle is the angular aperture. Here, this angle is the angular aperture. Here, we connect this. This angle is angular aperture. Now, if the aperture is less than 10 degree, then we call it thin spherical mirror. Now, we have images for different positions of the spherical mirror. Here, principal focus and secondary focus is also possible. Secondary focus is if a incident beam of light rays parallel to each other incident obliquely on the reflecting surface, obliquely with the principal axis, then they meet at a point on the plane which is perpendicular to the principal focus, which is called focal plane. Hence they meet at a focal plane, and this point is called the secondary focus. Now, in the next class, we discuss the images of object, linear object, for different positions with respect to the spherical mirror. Thank you.